Abdul Salam, professor in Department of Pharmaceutical Chemistry. So today we are going to have a look into limit tests. What are these limit tests? What are the various types? Why we are going to perform the limit test? What is its importance? And what we are going to get to know while doing the limit test? What is the importance and how we are going to perform the various limit tests? And what was the need we have included this limit test? So let us see what is this limit test. So here, limit test, what is this limit test? If we see ourselves when we perform, when you might be have done the practical, in this practical, you might have taken this test tubes, usually we call it as Nessler cylinders. So in which you have checked that turbidity and all. What was the need? So actually, these limit tests are there for identifying the impurity. These are there to check the impurity and to identify the extent of impurity present in them. Usually, we call them as semi-quantitative tests. So in this, what happened? We will be either checking the turbidity, we would be either checking the color change differences in the intensity, or we'll be checking the opalescence, and then we'll be identifying we'll be doing two test tubes. We'll be taking two Nessler cylinders, and the comparison between these two will be done, in which we will be checking out which one is having more intensity. So here, let us see about the definition to exact what is this limit test. So these are quantitative or semi-quantitative, which have been used to identify the impurities. So here, like there are certain limits that is being given. So beyond that limit, if these impurities are there that are harmful, that are not acceptable, because when we are going to get into, because we are dealing with pharmaceuticals, we are dealing with medicines, so we need these impurities, harmful impurities, toxic impurities to be there in the control. So here we have a certain value limit has been given in the pharmacopoeias. Standard limit has been mentioned, according to which each limit test have a certain method, certain procedure of preparation of standard and test, and then we will be checking out whether it comes within the limits or not. So like it has mentioned about various impurities, like you might be having gaseous impurities or organic impurities, inorganic impurities, metal impurities, dissolved impurities, suspended impurities. So these limit tests are mostly used for inorganic impurities, various metallic impurities that is there in the compound. So we will be checking about that. So why do we perform this? So here we will be checking these limit tests in order to avoid the harmful consequences that could be happen if that would be beyond the limit. Okay, so let us general principle, all the limit tests, you would be either having the color difference, means intensity of the color of our test has to be lesser than standard, because standard will give you the maximum value that is acceptable. So always, if you want a certain limit test to pass, it has to be either lesser colored or less opalescence, less turbidity. Then only it passes the test. Means that, okay, whatever the content of that metal, chlorides or sulfates, whatever it is within the limits. If it is having more turbidity, excess of turbidity, or excess of color, darker color, brighter color, it means that that component, that metal, that chloride, that sulfate is more in that, so that is not acceptable. So here, as why? Because these limit tests, they are not totally specified. Here we will be checking out known specified procedure with unknown sample, test sample. So that is why they would be called as semi-quantitative, because we are taking a standard with unknown quantity sample, unknown concentration sample. So here we'll have a sensitivity that will be checked, in which we will be checking out how sensitive the reactions is there, and then we will be need to keep them for at least 5 to 10 minutes after addition of all the reagents based on what limit test you are performing. They have to be kept for a certain period of time, 5 minutes, 10 minutes, so that that whole could react, and then we can compare these two standard with that of the test sample. So the major important equipment that is being used in limit test is our Nestler cylinder. Nestler cylinder, it varies. Usually we will be operating with 50 ml Nestler cylinder. It will be having a 15 centimeter height, and in that you'll be having 1 mm of difference should not be there. So having this specified standard shape and size will be there, and normally used will be of 50 ml. It also comes in 100 ml, but what we practically use in our laboratories will be of 15 ml standard Nestler cylinders. So we have to take precautions here. Anyway, Nestler cylinders are being a standard that will be available. They would be always colorless, and they should be here when you're going to check the turbidity. Okay, when you're checking the turbidity, because it is white color, nearly white or buff color, so that thing has to be observed in the dark background, black background, something you should be keeping. Then you can check, then you will be getting the exact correct differences. You can identify whether it is having more turbidity or less turbidity. And if you're checking the color, okay, any color with lead, with heavy metals, you might be getting this colored compounds, color changes. Okay, so the different colors will be there, shades will be there. So differentiating the shades will be much more easier when you keep them under the light background. So when you are comparing the color, then light background. When you're comparing opalescence or turbidity, dark or black background. So here, limit test mostly useful. This has been why this has been added up, because iron, sulfates, lead, heavy metals, all those things. You might have known that in 2015, this Maggie was being banned, and you might be knowing the reason behind was lead. Okay, lead was like it has to be at the limits of 2.5 parts per million should be there, but what they have found out that it has going beyond that limit. It's not just a single one sample. They have did with many samples, 30,000 some samples has been tested, and they found that they have giving this higher results, and that is why it has been banned. Nearly 5 million this Maggie outlets, like whatever the Maggie packets were there, that has been discarded, and it has been banned for a few months. It has ban was lifted later when the manufacturer has changed the formulation. It has decreases the limit, but still people now also they'll hesitate to buy because that it got that, like it has got that higher limit. So here, not only for Maggie, every food products, every pharmaceutical product will go through these standard tests. It will be performing all these tests in order to check that they are safe to consume, because medicines that are going inside our body. So we should make sure that it should not have any toxic content in it. So before manufacturing, before synthesis and all, these tests will be performed. So here, like if the chlorine, it has mentioned few examples here, like what problems you could happen if you're having these chlorine, iron, sulfates, that has to be if they are in higher quantities. Like if chlorine is higher in quantity, it could cause respiratory problem, blurred vision, skin irritation. Iron is responsible for various GIT diseases, stomach ache, constipation. Okay, so these impurities, okay, when they are in within the limits, like it's not like 100% they won't be there. We cannot make it. It is not possible. But we can make sure that we can check them that they are not under the toxic limit. They should not cross the toxicity level, so that they would be safe to consume. So that is why we will be checking out. So in this, we have only two results, either pass or either fail. It won't be anything in between, not acceptable. It will passes means accept. Fail means it will go for the not going to get into formulations. So here you can see in the image, like in this, you can see the limiters involve comparison of opalescence, in which you will be checking out the opalescence, whether it is light or dark. In that, you will be identifying higher opalescence means that content, whatever chloride, sulfate, whatever it is at the higher level. So here we have usually we will be sometimes turbidity. How it comes? Due to precipitation, you'll be getting that turbidity. Okay, color change you will be observing sometimes. You'll be checking opalescence sometimes. So these are the visual signs that we will be comparing in the limit test. Okay, so if the opalescence you can see in this one, like you can see that standard is little having higher opalescence when the test. So this one passes the test. Likewise, if you see the color here in this image, like test is having darker color than the standard, like your pink example has been mentioned. So this will be failing the test because it is darker, which means that that content is quite more in that one. Okay, so these are like quantitative, semi-quantitative, as I told, because in this we are going to comparing unknown with the known standard. So here let us see about first one, limit test of chlorides. So what is the basics thing? Usually it has been like comparing something failing or rotten with that of good. Usually we can just by seeing you can tell, okay, this is rotten, that is not good, and this is good, that is looking fresh. The same thing is here. If it is having darker turbidity, higher turbidity, dark color, which means that that content of chloride and all that is more, it should be discarded. So here, if you go towards chlorides, what are the various chemical reagents? What is the basic thing which we require? So here in chloride, we would be taking 1 ml of our standard solution of chloride. It has been prepared as per the IP standards, in which we will be taking 0.05845% of sodium chloride in an SLS cylinder, 1 ml. And in this test, we will be taking accordingly what sample we are taking based on that 1 ml solution of our test. Then we will be adding 10 ml of dilute nitric acid, making up the volume to 50 ml. You will have a mark on the Nestle cylinder. There will be a ring. That ring can help you to identify that this is the mark of 50 ml. So till that full ring, we need to fill up the water. Then we need to add up the silver nitrate, 1 ml of silver nitrate. Stir it with that of glass rod and observe. So these are the various steps. Like if you see in the stepwise, placing this test standard in the test tube stand, then we need to add our test samples, 1 ml and standard, then addition of nitric acid. After addition of nitric acid, make up the volume to 50 ml with distilled water, then add 1 ml of silver nitrate. Stir immediately, observe in the after 5 minutes in a dark background. You need to check out whether the opalescence is more or less. If it is more, test is more with the standard, it fails the test. If the test opalescence is less, it passes the test. So here it is given about if more opalescence than standard, it will be failing the test. So here, what happens actually, how it is getting that precipitate. So here, when you are adding this silver nitrate, we are having a sodium chloride we are taking as a standard, okay, or whatever the test will be having chloride, it will be might be in the sodium chloride in the various metallic chloride form. So what happens when you're adding the silver nitrate, it will form insoluble silver chloride. So this insoluble silver chloride creates that turbidity, that cloudiness, that precipitate like white colorness in that, okay. So due to which what happened, you will be getting that turbidity and opalescence. More the content of sodium chloride, more chloride will be there, more will be the opalescence or turbidity, it will be appearing. So that is the reaction. Silver nitrate gets converted into silver chloride when there is a chloride present. So this silver chloride is responsible for creating the turbidity. Higher the chloride, more the turbidity you're going to get. Coming to next is test for sulfates. So in this test for sulfate, we need to take a specific weight of our sample, whatever we are taking according to pharmacopoeial standards. Then we need to take 0.1089 weight by volume of potassium sulfate we are taking as standard in a Nestle cylinder. Then we need to add 2 ml of dilute HCl. So then we need to make up the volume till 45 ml. Then finally, with barium sulfate reagent. Barium sulfate is not purely barium sulfate. That is a barium sulfate reagent, which is a mixture of barium chloride and potassium sulfate. That will be, I will be discussing what is exactly this. Okay. Then we need to stir it with a glass rod. Then we need to keep it and observe the turbidity in a black or dark background. So again, we need to check it out, compare. If the turbidity is more, then it will be fails the test. If turbidity is less, then it passes the test. So if you go to a stepwise procedure, taking the stats and standard in the different menstrual cylinders, then addition of 2 ml of dilute HCl to each, then addition of 45 ml of water, then 5 ml of barium sulfate reagent. Stir immediately, then wait for 5 minutes. Let the reaction, that whatever the chemicals react themselves, then it will be giving us certain opalescence which we are going to observe. So here you can see if the opalescence, if the standard is more turbid than test, then limit test passes. And if the standard is less turbid than the test, then it is going to fail the test. So here, what is the role of various reagents here? So here, dilute HCl, why it has been added? Because it requires acidic condition. That is why we are adding this dilute HCl. Then only the reaction proceeds. And here, barium sulfate reagent. Why what it is? It is contains barium chloride, sulfate-free alcohol, and potassium sulfate. So here, this potassium sulfate is responsible for increasing the sensitivity. It will make a reaction more reactive towards the sulfate ions and will give you the turbidity in a better way. So that is why we will be adding this barium sulfate reagent, and alcohol will prevent the supersaturation of this liquid. Don't allow everything to get soluble. So that is why we are using. So this sensitivity is responsible by this potassium sulfate, which increases the sensitivity of this reaction and giving us the turbidity. Coming to next is limit test for iron. So in limit test of iron, we will be taking a standard amount of test or sample. So here we'll be taking iron standard will be taken according to pharmaceutical standards, and will make up the volume till 40 ml with water. Okay. After that, we need to add 2 ml of 20% citric acid. Okay, 20% citric acid weight by volume, and 2 drops of thioglycolic acid. This is very important. First, citric acid is being added up, then the thioglycolic acid. Then what we need to do, we need to add ammonia. Ammonia is being added up till the solution becomes alkaline. Check it out with limit like test paper, like with pH paper. Check it out how the until the test limit our pH turns into alkaline, we need to add it up. And as it turns into alkaline, pH paper shows that blue color, then we need to stop it, keep aside for 5 minutes. For both the same procedure, difference is here we are going to take test sample, here we are going to take standard. So here you can see the stepwise procedure, paste lacing to the different test tubes. We'll be taking 2 Nestle cylinders. In one we'll be taking our test, in other we'll be taking our standard. And then we will be adding 2 ml of 20% citric acid. Then we will be adding up 2 drops of thioglycolic acid. Then with the help of ammonia, we will be adjusting the pH to alkaline. After it goes into alkaline, let it stay for 5 minutes. Then we'll be observing the color difference. So if there is less color, light color, then it is passes the test. If the intensity of our test will be more, if it is giving darker color, then it fails the test. So here, what is the importance of each reagent, what we are adding up? So actually what is happening, iron, when it is being reacted with thioglycolic acid in presence of ammonia, it is forming this ferrous thioglycolate. This is actually pale pink in color. So this pale pinkness, it gets intensified into reddish purple if it is more iron is there in it. Okay. So here, what is happening? This thioglycolic acid is converting this iron into ferrous thioglycolate in presence of alkaline media, ammonia, gives that colored complex. But here, why we are adding this 2 ml of 20% citric acid? Because it will be allowing that earlier, whatever the other metals are there, that will create complex with citric acid. It will allow only iron to be available to react with thioglycolic acid. So it will prevent the precipitation of other metals. So that is why citric acid is quite important. So whatever the other metals are there, they would be first of all reacting with citric acid. Then we are having this iron freely available that is going to react with our thioglycolic acid. Coming to next is our limit test for lead. So in this lead, sulfuric acid is prepared in this. It is very important storage containers, and glass bottles are used for storage that will be having this lead for storage. Will be using this glass bottles. So here, what are the effects that could excess of lead content? Why we have, I just told you that Maggie was having this excess amount of lead, that what it was banned. So here, these are the things that could cause if we are taking excess of lead indirectly by either any impurities or by any sort of means. Okay, so here it could cause intellectual disability, it could cause irritability, memory problems, might be having problem to have children's, abdominal pain, tingling in hands and feet. All those things happen due to the excess of lead. So that is why its levels has to be kept in under control. So here, what happens in the limit test of lead? So lead, when it reacts with diphenyl thiocarbazone, it will be forming lead dithiocarbazone complex, which is red in color. So this is also happens in alkaline solution, and the reagent, like we will be taking phenol red as an indicator to give you the actual red color. And the pH here, it has to be kept above 8.2, or nearly it has to be kept not less than 9.5. 9.5 is the limit. If you go less than 9.5, what happens? Poisonous substance, hydrogen cyanide, could be produced in this reaction, and that is very much poisonous. So that is why we should take care when we are going to prepare, like going for this limit test. We need to keep the control the levels to not go beyond this 9.5. 9.5 less than, it should not be there. Alkaline, it should be there above 9.5, not below than that. Okay, so here how we are going to perform the procedure. Known quantity of solution will be taken up in the separating funnel. Then 6 ml of ammonium citrate will be added up. After that, we'll be adding 2 ml of potassium cyanide. That is what I'm telling. It is being used here. There is chances that if you are not maintaining the pH alkaline 9.5 or less, not more than that, then it could release this hydrogen cyanide gas. Okay, so that is quite harmful. So here potassium cyanide and hydroxylamine hydrochloride, that has to be added up. Then what happens? We need to add 2 drops of phenol red. After the addition of phenol red, both the solutions will be added with 5 ml of dithiazone until it becomes green. After it becomes green, we need to extract with dithiazone, and after that, we will be separating that with the help of all these things. Happens in a separating funnel. I'll show that thing how it happens. Then 30 ml of 1% nitric acid. Shake well. Keep aside until chloroform layer is formed. After they are going to form, then discard the chloroform layer. Add 5 ml of again standard diazine solution and 4 ml of ammonium cyanide. After addition of all these things, keep aside for 30 minutes. Let that color intensify maximum, how much color it comes. Then you can compare, test with that of standard, and you can see their turbidity, like color difference. Like if it is having more brighter color, test if it is having more brighter color, it fails at limit test. If the test is showing lesser color than that of standard, then it obviously passes the test. So here, our procedure stepwise, you need to take 6 ml of ammonium citrate, 2 ml of hydroxylamine, add ammonia till it turns alkaline, 2 drops of phenol red, 2 ml of potassium cyanide, and then extract with 5 ml of dithiazone until green. We need to add it until it will get the green color. So after that, you will need to add dilute nitric acid and discard. You will be seeing the formation of a chloroform layer. So discard that chloroform layer and then add 5 ml of dithiazone Then finally you add ammonium cyanide solution. Shake all the things after that and keep it aside for 30 minutes. So you'll see that you'll be having this sort of colors that will be obtained. So if you can see that it is darker color, this is our test, suppose, and this is our standard. Standard is both the same. So test is darker when that of standard, so it fails the test. Limit test is failed. If it is lighter, you can see that light pinkish, it is here little dark. So it is less color, so it passes the test. In this way, we will be comparing. Coming to next is test of heavy metals. Heavy metals is like, it could be like above 30 above metals that will be included in that. So lead, mercury, cadmium, copper, zinc, silver, gold, magnesium, aluminium, tin, iron, titanium. All these are heavy metals. They usually being tested in journal in this. So here we are having 4 different methods or 3 different methods that is being used here. So in this limit test of heavy metals, we'll be seeing based on the lead we are taking as our standard. So here lead will be hydrogen sulfide forms, lead sulfide, which is brownish red in color. So that will be there. So here, based on how much amount, like based on this much amount can be present in our test, based on that, we can choose what procedure. Usually 3 to 4 methods are there. We are discussing 3 here. So method A is used with the concentration if the sample is speculated to have 5 micrograms. If it is less, like between 2 to 5 micrograms, then we'll take B and C method. So let us see what is the A method. In the A method, we'll be taking the test blood in 25 ml water, adjust the pH with 3 to 4, and then by adding usually help of acetic acid will be adjusting, and then dilute to 35 ml and mix. Okay, so with the help of acetic acid and ammonia, one is acid, one is base, we need to make it to 3 to 4. Okay, so then add 10 ml of freshly prepared hydrogen sulfide solution. We need to add and then mix that whole to about 50 ml. Make it to water, dilute it to 50 ml. After 5 minutes, vertically see downwards over a white background. So vertically with that you can observe and you can see with the dark background how the color difference is there. So here this is a stepwise procedure. Dissolve standard, dissolve test, then adjust the pH 3 to 4, 10 ml H2S, mix, make up the volume to 50 ml. After 5 minutes, view the cylinder vertically downwards. So this is one method. Now coming to another method. In this method, we need to take moistened sample with sulfuric acid, ignite on low flame till it completely charged. Okay, or else and add few drops of nitric acid, heat it to 500, allow to cool, and 4 ml of HCl, evaporate to dryness, moisten the residue 10 ml HCl, digest for 2 minutes, neutralize with ammonia, make acidic with acetic acid. So first step is quite larger in B method. So here, because it is having a lesser content, so in this we need to make up it come out and show the color. So that is why we are igniting and we are charging up this thing. So next in this we'll be either taking the standard and dilute with 25 ml of water. Second, third, fourth steps which we have taken that are same, if you see the procedure stepwise, moisten with sulfuric acid, ignite on low flame, add few drops of concentrated nitric acid, 500 degrees, make heat and allow to cool, then add 4 ml HCl, evaporate all these things to dryness, moisten the residue with 10 ml HCl, digest for 2 minutes, make it wait for 2 minutes, then neutralize whole solution with acetic acid and ammonia to make it acidic. Then we'll be repeating the earlier stepwise procedures of the previous solutions. So coming to last method, the third method, like dissolve the specific amount in 20 ml of water, then we'll add 5 ml of dilute sodium hydroxide solution and make up the volume up to 50 ml with distilled water, 5 drops of sodium sulfide, and mix, set aside for 5 minutes and view downwards over a white surface. So in this way, we will be keeping up. So we can see that standard 2 ml standard lead solution will be taken. Here we'll be taking our solution in 20 ml of water, ml of dilute NaOH, make up the volume 50 ml, 5 drops of sodium sulfide solution, mix and set aside. Okay, so we vertically downwards are the white background, because here you're getting color. When you go towards lead, heavy metals, you'll be getting the colored compounds. So all these things will be observed in a white background. So you can just see that here, compare the brown color. If it is more color, limit test fail. If your stat test, it is having the darker color, it fails. Here it is not at all having, it's not giving, like sometimes it will be just transparent also. It means that it passes, it doesn't have any sort of lead in it. So that is why it is passing the test, not showing any color. Coming to our next limit test, that is limit test of arsenic. So for arsenic test, we are going to take a special apparatus, Gutzit apparatus will be taken. So here arsenic is also quite harmful poisonous substance. Its content is also has to be controlled and checked out, because it has a lot of complications could happen with the higher content of the arsenic, such as skin damage, hyperkeratosis, pigmentation, carcinogenic causes lung or bladder cancer issues, kidney and liver issues, circulatory problem, nerve damage. Lots of things could happen with this arsenic poisoning. So here, the Gutzit apparatus is being used. It consists of a beaker, bottle, which is being closed with a rubber glass stopper, through which a glass tube can pass. And this glass tube has a lateral orifice. It will be there, which is located at 50 mm from the lower tip. A second glass tube of the same internal chamber taken. Free ends of the glass tube are inserted into the triangular and then are held over other via means of clips. With the help of clips, will be holding these two together. So a disc or piece of a mercury chloride paper will be placed in between to the triangular rubber stopper, which connects the tubes. So 50 to 60 mg lead acetate cotton is loosely packed and inserted into the lumen of internal tube. So here, let us see what is the principle that is going to happen in this. So what is happening? Metal arsenic in the sample, it dissolves in HCl as an arsenic acid. Okay. Now, this arsenic acid is reduced by reducing agents, zinc, HCl, tin, stannous chloride, and potassium iodide. These are all reducing agents that are get reduced. After reduction, this arsenic acid is further reduced by nascent hydrogen produced by zinc and HCl. This gas, arsenic gas, which is going to evolve, this is being, when passed through the mercury chloride HCl2 paper, when reacts with HCl paper, forms yellow stain. So this yellow stain intensity, how dark, how bright that yellow stain is, it gives that amount of arsenic present in it. So you can see here reaction, arsenic acid, arsenious acid. This arsenious acid with the hydrogen that is being reduced, produced by various reducing agents, zinc, HCl, HNCl2 and all. And then it will be forming arsenic gas. This on reacting with mercury chloride paper gives you this mercury chloride arsenic complex. This will be staining the paper red. So we will be comparing these stains with that of test as well as standard, and we'll be checking how much darker or brighter stain it is. Based on that, it will be accepted or failed. So you can see first metallic arsenic in the sample dissolved in HCl as an arsenic acid. Then arsenic acid is reduced by reducing agents, HCl, SnCl2, zinc, potassium iodide to arsenious acid. This arsenious acid is being further reduced by nascent hydrogen, which will be produced by zinc and HCl. Then after that, evolved arsenic gas ascends upwards, and it will going to react with the junction of two where mercury chloride paper is present, that will be reacting and staining that mercury chloride paper to the yellow color. So the depth of the stain depends on the quantity of arsenic gas, and arsenic gas is produced based on how much arsenic is present in the sample. So if a standard is having a certain stain, so the stains will be compared. So you can see here HCl sample dissolved in HCl release HCl arsenic acid, converts arsenic to arsenous acid, converts into arsenic gas. HCl reacts with to form yellow color. Lead acetate soaked cotton traps any H2S gas that evolves during with the arsenic. So lead acetate and soaked cotton is being kept in between so that in order to prevent this H2S gas, it won't allow it to react with that the mercury chloride vapor. So you can see the procedure here in detail. So place a sample in 100 ml conical flask, white Morton flask, dissolve in mixture of water. Then here we'll be taking 1 ml of standard arsenic solution to 50 ml of water. Then to this solution, 1 gram of potassium iodide, potassium 5 ml of SnCl2, 10 gram of zinc. Immediately assemble the apparatus, immerse in a water bath provided and uniform temperature such that uniform evolution of gas takes place. Like a little lukewarm, you need to keep in a water bath both the apparatus, test and sample. And then after 40 minutes, observe the HgCl2 paper that has been placed. You need to keep it at a lower temperature or standard temperatures. And then we need to compare the stains, the yellow stains. So here, you can see here, a stepwise procedure, sample will be taken, dissolve in a mixture of water and HCl. Here we'll be taking a 1 ml arsenic solution and dissolve in 50 ml of water. So in this, to this solution, add 1 gram of potassium iodide and 5 ml of 10 chloride will be adding up and 10 gram of zinc. Immediately assemble the apparatus and you'll be need to check out the stain. So here you can see the stains here. So if the stain is more colored, it fails the test. Here standard color and test color. If test color is lighter than standard, it is going to pass the test. So here there are certain qualitative analytics tests for alkalis and earth metals. So presence of barium, it can be detected with the addition of dilute sulfuric acid with a test sample or yield precipitate with barium sulfate. Calcium presence can be detected by a dilute ammonium oxalate, and magnesium can be detected with the help of magnesium 8 hydroquinoline complex. Alternatively, calcium is present removed by calcium oxalate, and aluminium can be formation of aluminium hydroxyquinoline with oxide complex that can be done. It will be giving a fluorescence. So here, based on a presence of certain samples, this chloride and sulfate test has been little bit modified. So what we'll be doing, normally we'll take a sample, weigh a specified amount, dissolve in water, make up to 50 ml, then we'll be checking for chloride and there. But here, some samples vary the physicochemical properties like alkaline nature to be dissolved to dilute nitric acid or else instead of distilled water. So if the compound is alkaline in nature, then little bit dissolve in nitric acid or HCl instead of distilled water to make it little neutral. So here, water insoluble components, if they are like light kaolin, magnesium trisilicate, are generally boiled to corresponding acids and distilled water to get extracted and filtered. Then we'll take this filtrate and use for the test. Like samples which react with nitric acid, such as magnesium oxide, magnesium carbonate, calcium hydroxide. So they might be reacting with nitric acid to be dissolved in acetic acid first for making the sample. In case of metallic salts are there of organic acid like sodium benzoate, sodium salicylate. So free acids get liberated on shaking with mineral acid, like little bit HCl we'll be taking, then we'll be mixing it up. Then we will be making the test sample. Samples which are reducing agents like hypophosphorus acid, such sample can be reacted with silver nitrate in a test for chloride, therefore should be pre-oxidized before boiling with nitric acid before carrying the limit test. So it has to be pre-oxidized by boiling with nitric acid, then it has to be used for the limit test. Colored samples like potassium permanganate are pre-reduced by boiling with alcohol prior to the test. First of all, we'll be boiling with potassium permanganate with alcohol, while other substance like crystal violet, malachite green are carbonized to ash. They will be carbonized, burned to ash to the test, and then ash is extracted with distilled water. Filtrate is used for the sample. So that's it about our seminar, webinar. So here we can see in this limit test, we can see that we can able to identify the certain limits. So what is the basic thing all the limit tests will be having is checking out all of them. It is like they have to be lesser. We are giving a certain limit for the higher content, and all of our compounds or the test samples, they should have the lesser amount than that of standard. That is our basic principle for all the limit tests. Either they are giving color, either they are giving opalescence, turbidity, whatever it is. Standard value has been mentioned. According to that procedure, you need to prepare and compare. If it is giving more turbidity, if it is giving higher color, darker color, brighter stain, then it fails the test. It indicates that the whatever our sample we are taking, like either we are doing for iron, if we are doing for chloride, if we are doing for sulfate, whatever the component we are taking up, there are at higher quantity, there are at the higher levels. So that is why they are giving brighter color, darker stains, higher opalescence. So that samples will be discarded because they fails the test. So all these procedures are being performed to identify these impurities, and they have a certain, like if you go towards chlorides and all, they would be having a reaction with silver nitrate, or if you go towards sulfates, we are taking barium sulfate reagent. So initially we have seen for chlorides and sulfates, we are having opalescence comparison. But when we go towards heavy metals, lead, we are seeing that they are releasing colored compounds. Okay, these color compounds intensity we are measuring, and we are checking out that intensity has to be lesser when that of the standard. So this is our concept regarding the various limit tests which we are going to perform, which you might have done in your practical, in which you will be getting much more clarity how it fails. Usually, faculties, they will be giving one which passes the test as well as one which fails the test. That will help you to identify the difference between how and when they passes the test. So if they give such same things in your exam also, the practical, you need to see that. You need to follow up the procedure, then do that. And then if it is opalescence like chloride, sulfates, if it is there, use a dark background for comparison for their turbidity or opalescence. And if you're getting lead, heavy metals, then you need to check in the light background that intensity of the color, and then we need to observe the differences. If it is having more than that of standard, then it fails. Whatever it is, whatever the test of limit test you are performing, either for chlorides, heavy metals, lead, sulfate, iron. So whatever the limit test you are performing, always the test opalescence, turbidity, or color intensity has to be lesser than that of the standard. Then only it will be passes the test, or else it will fails the test. So major role for all this limit test, because why we are doing for all these limits? Because these chemicals, when they are being inside our body, they are causing toxicity, they are causing a lot of complications if they are beyond the limit. So that is why we need to check and control that whatever these metals or ions which are there, they have to be kept or taken up in the lower content or within the limits. Then only it will be acceptable. Then only we can use that raw material or food material or pharmaceutical product as for the human consumption. Or else, if it is beyond that, it would be causing harmful, and it is not going to be useful for us. Any doubts? Any questions? So this is the importance of the limit test, why this pharmaceutical drug has passed or failed the limit test. So how to find out? So this is the basic thing which will be coming up, checking out in this. That is, we will be taking our Nestle cylinders. We'll be checking that the sample with the rough standard, and we'll be checking out their opalescence, turbidity, or color. and then we'll be identifying which one passes and which fails the test. So here we have seen the various principles that is being involved in different limit tests. Okay, and in this we have seen about how each test is being conducted, what is the whole procedure that is being performed, and for each, what is the principle behind the use of chemicals. Like we have seen that for each and every reagent which is being added has an important role. That is why it is being included in that. Okay, if it is not there, it could lead into something else, or it could lead into certain poisonous substances. Like for example, if you take for HCN, okay, production of HCN happens if you're not going to maintain the alkaline medium in the lead limit test. If you're not going to make the medium till 9.5, make it alkaline, or else what happened? HCN is going to release because potassium cyanide is one of the reagents. Okay, so for each addition of each reagent, there is an importance of it that has to be included, and that is why we need to take care that each and everything has to be added accordingly. For example, if you take an example for heavy metals, in that we are going to add up citric acid. Okay, so we are adding the citric acid in one of the limit test of iron. Okay, so in this limit test of iron, we are adding the citric acid. It has to be added before the thioglycolic acid, or else what happened? That it won't be giving us the proper results, because if it is not been added, this citric acid is responsible for reacting with that of various other metallic cations. If it has been not been added, then other metallic cations might be reacting with thioglycolic acid and giving the complex, and we won't be getting that exact color or stain which we wanted, like color of the pinkish color. So that is why before we are adding with citric acid, making sure other metals will be stay reacted, then we are adding this thioglycolic acid, which will be again forming complex with iron to form ferrous thioglyconate. Okay, so in this way, we have different reagents which is being used in each limit test, has their importance, and they have to be added at their specified time before addition of thioglycolic acid. Citric acid has to be added up. If you're adding it later, you won't be getting the proper result, because what happened? Thioglycolic acid is going to react with the other metals also. So this stepwise procedures, each and every what has to be added up where, that plays very important role. That is why it has been this standard procedures are mentioned in order to give you the exact results, in order to give you the exact color, and then only you'll be able to properly check out the color changes, and you will be getting the proper comparison can be done. Okay, so basic thing you need to keep in mind that there would be any sort of color change or like a color production, precipitate formation, pallescence, turbidity. We need to see that our test sample should have lesser than that. If it is having lesser than that, then it is having the contents of whatever the metal, heavy metal, lead and all within the limits, and it is going to be further expressed. Okay, so we have seen about the lead, in that we are going using this phenol red solution. Okay, so in this lead we are using phenol red, and the pH has to be alkaline, then only it will be giving the proper color, or else and one thing, if we are not maintaining this pH above 9.5, this potassium cyanide might produce hydrogen cyanide, which is a very poisonous gas. So that is also quite important thing we need to take care of, or else it would be very harmful for us to whoever is performing. Okay, so we should be take caring of all the steps, then only we'll be getting the proper color changes, good result, and we will be able to get the proper comparison. Okay, so here you can see this will be using this separating funnel, where it will be extraction is being there with that of chloroform layer will be discarded, and then we'll be keeping it for 30 minutes, and we'll be getting the color differences. So if you go towards the heavy metals, in this we have many metals like from lead to silver, gold, and many more heavy metals are there. So all these heavy metal we will be comparing with that of different methods based on how much concentration the heavy metals could be present. On that basis, we are reacting. We are using a procedure. First procedure is quite simple, in which we need to simply add up with the drug with 25 ml of water, adjust the pH to 3 to 4, then add 10 ml of prepared hydrogen sulfide, then mix the dilute with water about 50 ml, then observe in a dark background. But whereas if you go towards the second method, in this we need to moisten with sulfuric acid. Okay, we need to moisten this solution with that of sulfuric acid and ignite it low flame to make it completely charged. Heat it, allow it to cool, 4 ml of HCl, evaporate to dryness, then whole residue with HCl will be digested for 2 minutes, neutralize and make it acidic with acetic acid. Okay, so in this way, we'll be doing the first step. Then the next steps which are there that will be followed of the method A. So in this way, we have different methods that will be performed in order to get this heavy metal test completed. Like for method C, dissolve specified quantity in 20 ml water. Sodium hydroxide is being used in C method and make up the volume for 50 ml water. Then sodium sulfide is being used for getting the color. Okay, so mix and set aside for 5 minutes. View from the downwards against the white background. So you can see the color difference. So if it is having more color, it fails the test. If it is having lesser color, it will be going to pass the test. And for this arsenic, if you go, just if you see that arsenic, it is used for limit test of arsenic. In this, we will be getting a stain. Okay, stain will be there. A special apparatus called as Gudsient apparatus is being used for this arsenic limit test. Okay, so in this, we will be having a special arrangement of a beaker bottle closed with a rubber stoppers in through which a tube will be passed, and then we will be holding with the clamp, and in between we'll be keeping our mercury chloride paper to get the stain. So here we'll having a reaction between arsenic acid, which will be either present after dissolving the arsenic with the HCl. First we will be adding HCl, so it will form this arsenic acid. This arsenic acid with the presence of